Okay, I just wanted to cover a couple things that I saw in week 2 homework that you guys were struggling with. So the first thing that I saw was writing the equation of a line through 2 given points. So remember, to make a line, you need 2 things. To make a line, let me make that pen a little thinner. To make a line, you either need a point and a slope, or 2 points. Now, either way, if you have 2 points, then you can find the slope, and then you can follow the point and slope rules. So if you know a point and a slope, you're going to have 2 options for what you're going to do. Thank you. Okay. So there's 2 kinds of equations for the line. So you could either use y equals mx plus b, where you're going to plug in your x and y and your m, find b, and then write the equation. Or you can use point slope. And point slope is y minus y1 equals m times x minus x1. So if you know your m and you know your x1 and y1, so you'll plug in x1, y1, and m. So either way, whatever you're given, right? You're either given 2 points or you're given a point and a slope. If you've got 2 points, find the slope, and then now you have a point and a slope. And then you can use either option A here, where you're using y equals mx plus b, or you can use option B, which is the point slope form. The reason I like the y equals mx plus b is because if you've already, like most people, when you say, what's the equation for a line, they'll say y equals mx plus b. So you already kind of know that formula. So I like to show you that you can just use that without memorizing an additional formula called point slope. So let's look at these 2 guys. So I've got the point 3, -6 and the point -1, -4. So to find the slope, it's going to be rise over run. Now, rise is how much you've changed up and down, up or down, and run is how much you've changed left or right. And to calculate that when you don't have a picture, you can subtract your y's. So up and down is a y number, and then left and right is an x number. And the one thing to be careful about here is I don't care which one of your x's you label as x1, its partner has to be y1. So the order that you do the subtraction matters. So I'll call this one x2 and y2. So for our example here, we're going to have -4 y2 subtract y1, -6. Big divides. Then we're going to go in the same order, and we're going to do x2, so that's -1 subtract, and then x1 is 3. And again, before I do my calculation, and I just want to check that I've written my values right, as long as you know y stuff is on top and x stuff is on bottom, if you look, these this pair, -1 and -4, is on top of each other, right? The y is on top, the x is on bottom. And then if you look at this pair, 3, -6, you see -6 is on bottom, on top, and 3 is on bottom. So that's how I double check that I've I've picked them properly and put them in the right place. And then we'll just do this calculation. So -4 subtract -6 turns into -4 plus 6. So that makes +2. And then -1 subtract 3 is -4. So if I simplify this, and again, if you need to know, like if you don't remember simplifying, 2 goes into both of these. So I'm going to divide both of them by 2, and I get 1 over -2. And now that's a fine way to write your slope. You can have a negative on bottom, but generally, if there's only one thing with a negative, we either write it on top or outside. So you could write this as -1 over +2, or you could write this as negative and then +1 over 2. So only one thing's getting the negative. Generally, I prefer when I'm writing to just put the negative on top so it doesn't get lost, but it's really up to you. So now, let me show you how to use y equals mx plus b. So we found our m was -1/2. And then we can pick any one of these pairs, either the yellow pair or the blue pair, as my x and y. I'm going to use this first guy here because it's got less negatives in it. It doesn't actually matter. So my y will be replaced with -6, and my x will be replaced with 3, and then I have plus b. So -6 equals -3/2 plus b. And to get the 3/2 onto the other side, I'm going to have to plus 3/2. So the math I need to do is +3/2 subtract 6 equals b. Now you want to keep this as a fraction, and if your calculator could do a fraction, great. If it gives you a decimal, you shouldn't use it. So if I want to make these guys the same bottom, I have to multiply this guy's bottom by 2. So I'm really doing 3 minus 12 all over 2, which is -9 over 2 equals b. So what this tells me is that y equals -1/2 x minus 9/2. So I just rewrote the b part here. Now this would have worked and we would have gotten the same blue answer had we used the other point, -1, -4, had we used both points in point slope form. So now since Alex shows point slope form, let me also show it here. So the option B, so this was option A. Option B is to use point slope. So if you remember it, you could use it. So I would have, again, you could pick either one of your pairs of points to be your x1 and your y1. So I'll still use the purple pair. So I have y minus -6 equals m -1/2 times x minus 3. So y plus 6 equals -1/2 x. Now, -1/2 times -3 is positive 3/2. And now to get y alone, I'm going to subtract 6 from both sides. And you see how this kind of already worked out with the same math? I'm going to have to do y equals -1/2 x and then plus 3/2 minus 6. And so the same math that I did over on this left-hand side, I've got to make the bottoms match. So when I put these two pieces together, I get negative 9/2. So my equation is y equals negative 1/2 x minus 9/2. And I got to the same exact equation. So it's your choice which one you use, option A or option B. What I like about option B is it kind of has the slope formula built into it, right? If you just divide both sides by x minus x1, you'll have y minus y1 over x minus x1 equals m, which is basically the same as this guy besides the subscripts. So then another thing I saw was finding the domain and range of a graph. So there are a couple things to look at when you're looking at a graph. First of all, the domain is your left-right. So if I was like shining a light down onto the x-axis, the function is like a wall and it blocks. So it blocks all of this in here. And then when I go upwards, when I shine my light from this side, this will shine from -3, and this side will shine up to +3. Now, very important, this guy's x value was open versus this guy's x value is closed. So the domain of this graph, the x's that had a y that went with them, start at -3 and go up to +3. Now, since -3 is closed, it gets a square bracket, meaning, okay, get as close to -3 as possible, and also you could use it. But now over on the right-hand side, if I want the +3, well, that only corresponded to one point, which was open, and so I'll use an open bracket, and that tells the reader, hey, get as close to 3 as possible, but you can't actually equal it. And remember, we could play the what's closest to 3 game for the rest of our lives, for the rest of the universe's life. Now, range is similar, so let me erase all my highlighting on this. Okay, so for range, we're looking at the y values. Now, again, you can kind of think of your function like a wall, and you're shining your light from left to right. What do we get colored in? All right, so think of shining your light this way. Where's the shadow? Well, on this side, the shadow starts at -4, and it goes, as my eyes go up, up, up like this, the shadow is going up, up, up to +5. And then as I travel this side, my shadow is going down, down, down. So from +5 down, down, down to -4. Now, this -4 on this side is open. But the thing is that when two values have both an open from one point and a closed from the other point, the closed will override. So since on the left, -4 actually has an x value that goes with it, it will close off the -4 in the range. So the range, which, let me write it. Oh, I picked blue. Let me write it in green. So the range is lowest to highest. So the lowest the graph goes is -4, and the highest the graph goes is 5. So now, -4, we decided that since this coordinate, -3, -4, is closed on the graph, then that x value -3 is included in the domain, and the y value of -4 is also included in the domain. So -4 is included. And now the highest it went was 5. And you can see on this graph the location 0, 5 is on the graph, like it's an actual point, and so 5 is also included. So when you're doing domain and range, first it's important to understand how to read the graph, but then also how to decide which kinds of brackets you're going to use. And if even one symbol is wrong, then the whole thing is marked wrong. So let's try, I've got 2 more here. So in this one, we're looking which x values have y values that go with them. So like if you look over here, there's no function over there. There's no function, there's no function, there's no function. Hey, the function started. So my function is going to start here at -3. And now again, where are the points that have y values? Well, that would be all of the points in here, and then a little bit more up to 2. Well, it's not letting me erase it with my pen properly. How would I erase that way? Okay, so now let's write that out. Now this -3 as my x, that point was not included. So domain is going from -3 to +2. Now -3 is not included because that point on the graph was not included. And then 2 corresponds to this point here, which is also open. So the interval will be from -3 to 2. Those are the x's that I'm allowed to use. That's like saying x is allowed to go between -3 and +2, but can't be equal to, so we wouldn't put equals. Now for range, we're looking at what y values have x values that go with them. So like we never get y is 5, right? Because if you look at the y equals 5 line, it doesn't touch the function. So we're looking at like how low and high the function goes. So if I'm thinking of like kind of shining light from the left side of the y-axis, the shadow will be starting at 0, right? It'll be open at 0, and then it will shadow everything up to 4 and then back down to 3. So it's okay if it happens more than once. Then if I come from this other side, right, thinking about the function shadow on the y-axis, this side shadows from 3 down, 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 down to -5, and -5 was not included. Now something kind of crazy happened here. So I think you should understand why -5 is not included. But what happened to y equals 0? So this point, -3, 0, is not included in the domain, right? It's got that open symbol. So it's like, hey, get as close to this point as you possibly can, but don't actually get to it. But then right here, this point is 1, 0, and it is included in the domain and range because the curve is really just a bunch of coordinates so close together that it looks like a smooth curve. So even though 0 was not included on the left when we used -3, it is included as a y value from the right-hand side when x was 1. So the range of this graph, lowest to highest. So the lowest this graph goes is -5, and the highest it goes is 4. Now, -5 was not included, and 4 does actually have a point that goes with it, right? -1 comma 4. So 4 is part of the domain, or part of the range. So it will be or equal to. Now, in this last example, you should try to pause the video and see if you get the same thing as I get. So our domain is going to start at -2 and go up to 3. And the range is going to be as low as -5. And it's going to go all the way up to 4. So let's write that down. The domain starts at -2 and goes to 3. And the range, lowest is -5 and highest is 4. So now we have to just double check whether they're included or not included. So the point here is it included. -2 comma 4 is part of the graph. So 4 is included and -2 is included in the range and then domain respectively. Now, it goes down, down, down to -5, and -5 came from this point here, which is 1 comma -5, which is on the graph. So -5 is also included. Now, the only kind of question here is at -1. The location 3, -1 is not included. So 3 is not part of the domain, and -1 would not be part of the range. But the thing is, with range, your range can repeat. Remember, vertical line test says x's can't repeat, but y's can. And so when I have this point over here, which is -1, -1, that is actually included, and it closes up the open from the 3, -1 on the range. So 2, let's put our brackets in here. -2 on the domain is included. 3 was not included. And for the range, -5 is included, and it goes up to and includes 4.